In today's lesson, we'll be learning about and practicing dividing fractions using models, meeting the requirements for TEKS 6.3a and 6.3e. Before we start dividing fractions, let's start with a reminder about division using whole numbers. In this example, 10 divided by 2 equals 5. We know that the verbal description of this problem could be written as 10 divided into equal groups of 2. 10 divided into equal groups of 2 should give me 5 equal groups of 2. Well, let's see how this works. If I have 10 counters, each one of these counters represents a positive integer. So these 10 yellow counters represent my 10. I'm now going to divide these counters into equal groups of 2. Here's a group of 2, here's a group of 2, and a third, a fourth, and a fifth. 10 divided into equal groups of 2 equals 5. There are 5 equal groups of 2 to make 10. Let's try an example now using a fraction. What if I had 10 divided by 1/2? Or 10 divided into equal groups of 1/2. Each group will be the size of 1/2. So I think we agree that these counters here represent my 10. I have 10 full counters that I am now going to divide into equal groups of 1/2. So I could just repeat the same 10 counters below. These would be exactly the same. The picture on top with 10 full counters, the picture on the bottom with 10 full counters. Only what would happen now if I cut each of these counters in half? Because I'm not looking for groups of 1 whole, I'm looking for groups of 1/2. So this would be 1/2. And this would be 1/2. And this, and that, and this, and that. Each part of these counters is 1/2 of the counter. So if I took the 10 counters that I had and I cut those 10 counters into equally sized groups of 1/2, we would have 20 halves. We would have 20 equally sized groups of 1/2. These 20 equally sized groups of 1/2 fit inside of 10 wholes. 10 divided by 1/2 equals 20. Let's try an example with 2 fractions. So if I have 1/2 divided by 1/6, then I have 1/2 divided into equal groups of 1/6. In other words, each one of these groups will be 1/6 in size. So if I have 1/2, I take my entire counter and I cut it in half. If I draw another counter immediately below it, the same size, only this time instead of cutting it in half, I cut it in 1/6, so that each piece of this counter is cut into 6 equally sized groups. How many 1/6 are there in the same size as the 1/2 of the counter? So in other words, I have 1/2 of a counter right here, up top. If I take the counter down below and I outline just the half that I have, how many 1/6 are there? And it looks like there are 3. 1/2 divided into equal groups of 1/6 is 3. There are 3 groups of 1/6 inside of 1/2. So let's try another example. What if I have 1/5 divided by 1/10? I have 1/5 divided into equal groups of 1/10. I'm taking 1/5 and I'm going to divide it into groups of 1/10 that are equally sized. So, what if I drew a fraction bar? This bar represents one entire thing, one whole. If I took this bar and I cut it into 5 equally sized pieces, each piece would be 1/5 of the entire bar. And that all 5/5 would equal one entire thing. So now, what if immediately below this bar, I drew a second bar? Same size. Only this time, instead of cutting it into 5 pieces, I decide to cut it into 10. Would you agree that each piece would be 1/10? And that if I had all 10 pieces, I would have 10/10, and 10/10 would give me one whole thing. 1/5 divided into equal groups of 1/10. Well, if I have this 1/5 right here, how many groups of 1/10 are the same size as 1/5? How many 1/10 can I fit inside of 1/5? And it looks like 2. 1/5 divided by 1/10 is 2. Let's try an example using a mixed number. What if I have 3.5 divided by 1/4? That means I have 3 1/2 divided into equal groups of 1/4. How many equally sized groups of 1/4 can I fit inside of 3.5? Or 3.5 divided into equally sized groups of 1/4 will give me how many of those equally sized groups? So let's draw a picture. That's 1. That's 2. That's 3. And for this last one, we'll cut it in half so that we've got that half right there. We have 1, 2, 3, and a half. Now, what if just below it, I drew exactly the same picture? Only this time, remember we just have this half, I cut each one of these holes into 4. I'm making equally sized groups of 1/4. Each one of these is 1/4. And when I have all 4/4, I have one whole. So if each of these is 1/4, and the drawing on the bottom matches the drawing on the top, how many equally sized groups of 1/4 show the same picture as the 3.5 on top? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3.5 divided into equal groups of 1/4 is 14. There are 14 equally sized groups of 1/4 in 3.5. So how would this work if both my dividend and my divisor were mixed numbers? 2.5 divided by 1 1/4. 2.5 divided into equal groups, right? Equal groups, groups that are equally sized. They are each 1 1/4. So 2.5. I think we'd agree. 1, 2, and here's my half. So if below it I draw a picture using the same counters, only this time I cut them into fourths. And we agree that this half is the same as this half. So the bottom picture and the top picture are the same picture. I need a group of 1 1/4. So we agree, here's 1 and here's a 4th. So that's a group. And then to make one whole, I need 4/4. So I need this piece, this piece, this piece, and that piece to make one. This, and this. Those are 4 pieces where each piece is 1/4. Those 4/4 make one whole. I need 1 1/4. So I also need this piece here. So that I end up with this and this making one group of 1 1/4. And these pieces and this piece make 1, and here's 1/4 for 2 groups. I have 2 equally sized groups of 1 1/4 in 2.5. So that 2.5 divided by 1 1/4 is 2. There are 2 equally sized groups of 1 1/4 in 2.5.